The thing is that I saw a photo. There was I don't remember how long ago now, on the internet, and it turns out that Jérôme, my partner who I work with, had seen it too on his side, but it was very, very long ago. You know, on the internet, these two photos, which showed the exterior of Vapiaca, so with the entrance that is carved, and the interior with its walls completely smooth like Miros, and especially.
And so, Barabar, these are caves in India.
These are caves in India. That's it. But at that time, I didn't even know there were caves in India. We saw that photo and said, hey, one day we should go check that out. And it was while doing Builders of the Ancient World that, well, the idea came back. Let's explore that. So we went a bit blindly, because we didn't know. I had some writings, but, well, not really convincing. Well, in any case, it doesn't allow you to get an idea. At some point, you have to go there because a photo can be taken in one way or another. That's why we try to be very thorough in the film and to show everything. And so when we arrived there in 2017, it was in January 2017, well, it was a shock because being used to seeing carved rock a little bit everywhere, we had never seen anything like it. And the only granite surfaces which were more or less similar to what we find inside Barabar were the sarcophagi of the Serapeum in Egypt, at the Saqqara site, where there are granite boxes that weigh several dozen tons, which were placed underground with lids, and the inside was cut out. These are blocks. What was removed is parallelepipedic. It's mirror polished and just extraordinary.
Yes, because these caves, in quotes, were really excavated. I mean, they were dug into the granite.
We're inside huge granite rocks where entrances were cut and then they entered. So when I say we, it's not us, you know. They went in and they created volumes that appear simple. So that's what we discover. We discover shapes with vaults, slightly inclined walls. It's very surprising, very little light inside, if not none at all, everything, and an effect on the sound, on the voice, because first it's our own voice. Very surprising, even really unsettling. And there we try to measure them, we try to see. So we use the roughness meter. We realize that it is incredibly smooth. We try to measure them, but since the walls are inclined on both sides, we put the rangefinder and it hits a bit low opposite. So we say to ourselves, it's not very serious, we'll have to cheat the rangefinder. Already, sometimes we are criticized for not conducting real metrology campaigns, because when we measure, we don't just take a measurement and say, look, it's this much. We average measurements all around and so on, and we take a large number of measurements to verify all that. But we're not metrologists. It takes a lot of time. We don't always have, the time, the resources to stay as long as we would like on the sites. So we think there's something weird anyway, and it stays in our minds. We think we should go back. Not planned to return during BAM, since it was during the film. We'll do what we can with what we have, and it's the first sequence we see inside BAM and elsewhere, which ends by saying, convinced that we should go back because we had seen our roughness meters, we had seen that there were all sorts of things, we had enough to intrigue us. And it turns out there was the possibility to do 3D scans, and I asked, because we didn't have any money at all left for the film's budget, so I asked this company. They must have gotten a bit fond of us, and they gave us a great rate. And well, it was still very expensive because these techniques are costly. And we took the operator, the 3D scanner, and we went there and spent 3 days doing that. While we were conducting sound recording experiments as well, we were beginning research on acoustics. And so we weren't far from, there was a first version, which was the beta version of BAM, and it was completely modified afterwards and changed. And we were reaching the end of that. And then we have a GP who gives us the first plans and tells us, well, it's symmetrical, the rooms are symmetrical. We had already been faced with the concept of symmetry with the statues and heads of Luxor. We didn't have 3D scanning back then, and the American researcher who had, the engineer who had worked on it didn't have 3D scanning, as that technology didn't exist at the time he went there. He had worked with cameras and then reinterpreted by computer with specialized software for that, And So here we see that it's symmetrical, and we realize that, well, it's strange. We see that it's really because originally there were real portions of circles. That's what came out immediately. The work hadn't been pushed further. We hadn't realized that the curves were much more complex. And so we have 2 or 3 pieces of information that come out like that and tell us, there, but it's astonishing symmetrical. It means that these people go inside, and in addition to making shapes, which are still quite astonishing geometric shapes, completely devoid of inscriptions, representations of religious icons, statues, anything. So very, very austere. And now it's symmetrical. But what we lacked, and this is what an astrophysicist whom I met at CINES told me, and he said he was very, very intrigued by the Barabar chambers. That was after BAM. He told me, but I am a scientist, I consume data. So you say it is symmetrical. I want to know how symmetrical it is. I want us to quantify this symmetry. I want to know the margins of error, etc. And so it took us a little time to fund this report. We got the scan analysis report, and when we received that, well, everything changed, because we were faced with completely new and unprecedented information.
That is to say, could you elaborate a bit on these results? Would you still say that it is one of the most enigmatic sites in the world?
Yes, if not perhaps the most enigmatic. It is much less spectacular than the Great Pyramid because, as I said, the Great Pyramid is 230 meters on each side, 140 meters high, the equivalent of 2 million stone blocks. It's a gigantic construction site, to say the least. There, it seems simple at first glance, but precisely, that's why we dedicated an entire film. It's because we have no point of comparison. These chambers are unique in the world. So there was no other place in the world that closely resembles what was done at Barabar and Nagarjuni. We have geometric shapes that are simple in appearance but actually complex, requiring even in 3 dimensions to match several shapes together like ellipsoid shapes. So flattened spheroids or several spheroids of different diameters. And to be able to join them without feeling the junction between the two is not obvious. Already in theory, it is not obvious. In practice, it is even more difficult because we need special templates. From the moment it is no longer something circular, these are templates that must be used. But what makes them astonishing is that they were made with modern precision. We have angle variations of a few tenths of a degree over 5, 6, 7, 8 meters in length. We have shapes that repeat, which are mirrored. We have the walls that are slanted, the large walls around 87 degrees. The small walls are slanted at different angles. In fact, there are only technical specificities. It feels like this site was made by engineers and not by artisans, by artists. Obviously, it's stone carving work, so there are carvers, but carvers who worked as if they had specifications and as if they were guided by engineers. It seems, and that's what the stonemason says in there, he says, no, but it's not. We don't work to please the eye. Working to please the eye means it's beautiful, it's pleasing. But if we start using measuring tools to check the angles or whatever, you will realize that it's a little off, not completely parallel or things like that. But here he says, no, but this isn't work to please the eye, it's technical work. So it's a technical object. There you go.
And you specifically mentioned that there is a sound reverberation of 70 seconds at certain frequencies in the cave, which is exceptional. Is it finally in such a small one?
It's a Vadatika. It's a chamber that is 4 meters and a bit in length, so 4 or 5 meters. So it's really very small. It has a rounded shape. When viewed from above, it looks like an Eskimo. This one is quite crazy. It is very, very astonishing, and one does not expect in such a small space to have reverberation that lasts 70 seconds.
For comparison, it's between 10 and 15 seconds at Notre Dame,
which has a gigantic volume. Here we are on something that doesn't look like much either. It's in the low frequencies. That's quite astonishing. But the sound experience inside these rooms is truly astounding. I went to the Abbey of Toronnet the abbey or the monastery, donc the abbey of Toronnet, I believe, which is in the south of France, known as one of the most magical places for singing Gregorian chants, etc. Well, yes, it's pretty, but it's not Barabar, you know. Barabar, it's something much more... it feels like Barabar is the quintessence of ancient temples, because the ancients have been concerned with sound for a long time. The Greeks with their amphitheaters, the Romans as well. So the Greeks with their temples, the Romans with their amphitheaters, were really dealing with the management of acoustics. Shows were performed that could be heard by everyone without a microphone, so it has always interested the sound. But Barabar, it feels like all those temples that are immense, decorated, etc., that we took the sound principle, the quintessence, and that's just what we did. So that was done before.
And it is perhaps that principle which was then developed in the temples, I don't know.
But yes, the sound experience, it is very strange, very astonishing. The voice comes back amplified very strongly. Sometimes it's more than 60% for the voice. And when you are on the resonant frequencies, when you hit the resonant frequencies of the volumes, you can hear the harmonics of your own voice. So high musical notes in your own voice. In fact, you hear your voice like nowhere else in the world.
And so it was certainly perhaps designed for it's always difficult indeed. The traditional explanations is that they were caves for sheltering from the rain or something like that. Given the results you have found, what do you think? Wow.
So there are already two sites. There is the site of Barabar and the site of Nagarjuni. On these sites there are small plaques. Well, they are not small plaques because it is engraved directly into the rock. On the outside of the granite rocks, there are inscriptions that were made which are really not clean, not professional. That is to say, the stonecutters say those who made the inscriptions did not know how to sculpt. It is a craft, a discipline there. And you can see it in Egypt, for instance. You can see it in other places where Sanskrit has been engraved. It's magnificent. That's not the case here. It's not very beautiful. The letters, the depths are not consistent. There is no technique. In fact, there is no technique at all. So he says that it was done by the one talking about it on site. He says that it was done by someone who had absolutely no mastery of engraving. Because if one had even a minimum understanding of engraving, I mean, a painter recognizes another painter anywhere in the world and at any time. So an engraver sees that this was not done by an engraver.
So it seems surprising to have so much care for volumes with complex shapes, with an attention to detail that makes it worked on, and that it seems to be
easy to work with modern precision. We don't know now how it was done. And outside eye, finding this written, it's a bit like if you had, I don't know, a Ferrari and then someone writes Ferrari with a knife tip at the back. It's a bit strange. It ruins the work. And so regarding the pillar-to-pillar chambers, there is no function given for these chambers. It is said that it is the king who offers it in his 12th year of reign, that is 12 years after taking office. King Ashoka offers this chamber to the Ajivika sect, which is a religious sect, and of ascetic beggars who lived mostly naked, who had some very austere practices. It was a lot about asceticism, so they lived in total deprivation.
What year is that, according to the narration?
300 years before our era, so approximately 2,300 years ago. And then we have the Nagarjuni site, on which there are other inscriptions that are made in the same language, which is Brahmi. And there, however, a function is given. That is to say, it is said that it is Dasharatha. So the son or grandson of Ashoka, we don't know, since all of that has been erased for nearly 2,000 years. The son or grandson of Ashoka, who bequeaths his chambers to the Ajivika so that he can protect himself from the elements, but at the time of the rainy season, the monsoon. The simple fact that this is written, either we are dealing with symbolic writing, they are talking to us about the monsoon, because we are being told about astronomy or something like that, or I don't know, or it refers to something for which the reference has been lost today, but something sacred, grand, since it's a royal gift to a religious sect. So we expect him to offer something other than shelter, or a divine shelter, a sacred shelter or something, which is not the case in the way it's stated. And above all, we think that we place ourselves on, since it is difficult to determine the tools, we say, okay, let's use the cohort of rudimentary tools, picks, chisels, and then we come to polish afterwards. It represents a monumental task. One room takes a minimum of 10 years, according to the stonecutters who are used to carving, so they know.
And with modern tools.
No, even with the ancient tools, they know, and as the work progresses, they find it difficult to estimate because, in fact, roughing out the shape can go relatively quickly. We know more. I don't know how much it is per cubic meter per time. It can go relatively quickly. On the other hand, going from a rough shape to these symmetrical forms in length, in width, polished like a mirror, the respected angles, that precision. So there, it's something else. And there, we don't know how long it takes to move from one to the other. But if contemporaries of this construction, realizing the projects it represents, it's stonemasons working for 10 years in the same place, and who will work with a finish that is like this, with symmetry. So it really requires very particular care if they write that these are simply shelters against bad weather, when a single cavity would have sufficed. It's that, in our view, when these inscriptions were written, we were not already contemporary with the project. That is probably, moreover, the Indologist we interview in the film, who thinks that the inscriptions, those inscriptions are later.
So the caves would date from well before, at least a period we don't know about there.
That's it. It's very difficult to estimate since we can't date the carving of a rock. So we can date the granite deposit there. We can know when it dates from. And on the other hand, the moment when it was carved, that we cannot determine. So what could allow us to carve it is to find the rubble. And the rubble, which is probably somewhere in the underground, because it still represents a block that is 100 meters long, 40 meters wide, and 1 meter high for the 7 chambers, if there are 5 completed and 2 unfinished. So that volume should be somewhere. And if we had the possibility to locate it with ground-penetrating radar, so the tools that will allow us to scan the underground without digging. So as a result, it is non-destructive. That's the good part. If we had the possibility of finding that rubble, and that all this must be done according to the highest standards, it is not us who would do such things. It involves collaboration with UNESCO and the Indian government, on-site archaeologists. Everything must be protected with no pollution. The archaeologists are covered in protective suits. There must be no organic pollution. And then, at that point, if we manage to find organic material among the rubble, we could get an idea of dating and know when this rubble ended up underground. And then, by analyzing the surfaces, we could maybe try to determine what materials were used to cut them. That would be quite good. Leica, the company, is ready to support us in doing this. So we just need to get permissions in place, and we will see if we can do it. If we find this rubble, they must be somewhere, and we think they did not throw them 10 kilometers away. So there's this issue of dating, which is complex. And then especially there's the fact that we're talking about 3 chambers. We need to try to also properly place in context when the inscription says that King Dasharatha bequeathed them upon his arrival on the throne. So if he bequeaths the chambers of Nagarjuna, the second site, upon his arrival on the throne, it means the chambers were made before he was on the throne. And the one who preceded him was Ashoka. So it was done during Ashoka's reign. So the 5 chambers, 7 in total, but the 5 completed ones were made during Ashoka's reign, which lasted 28 years. So when we say 10 years, it means you need to have teams that are large enough to work on chambers in parallel, as what the stonecutters taught us. You also need to have left-handed stonecutters. It might not seem like much. Why? Because in certain places, as we are indoors, you can't strike with your right hand. You have to strike with your left hand to get the angle, because you're going to strike the surface in that way. These are details, you know, but they discover a lot of things, and actually about the, well, I'll maybe do a little bit of publicity because the film is freely available on YouTube.
We will put the link in the description.
Yes, so, well, when it's free, you are the product, so it's monetized. Now, for those who want to watch without ads and who like what we do and want to help us finance the continuation and fund our research, because actually we fund our research through film production, it has reversed. I was a filmmaker at the beginning. Well, more and more we're becoming researchers, and And so, well, as a result, we have a streaming platform, so we will also provide the link, and there you can watch the film without ads, and you can especially see the bonuses that we put alongside. And in particular, we have the tours of the 6 room tours with the stonemason we brought on site, and who, moreover, was able to determine by running his hand over the porch that the porch on one of the rooms, the only room with a porch, is a later addition. So the question arises why no stonemasons came before to do it, but that's not our concern. But so there you go. The expertise of the stonemasons is really very, very, very interesting. So for those who want, they can see these visits, and notably what I mentioned, the junctions of different shapes when the stonemason runs his hand in the Vadatika chamber and says, but it's incredible, I feel nothing. And he is astonished. And when a stonecutter with 40 years of experience is astonished and can explain these things and speaks with great humility, it's nice in these times when everyone sticks to the truth.
But with the techniques of the time, is it plausible to perform that work? Or would modern techniques be needed for that, for example? What do stonecutters say about the plausibility of it being done with the tools of the time?
Stonecutters have considered some mechanical tools, but mechanical tools, it's not a Black & Decker sander with a cable and a plug. Maybe counterweights with impactors to precisely be able to explain. There are some of them who can explain the regularity. There are others who say, I don't know how it was done. Some say it's impossible.
And even today, would it still be impossible to do?
It's difficult. We have no point of comparison. It doesn't exist. We have inquired. We have informed ourselves. Stonecutters are very knowledgeable about everything that has been built in stone, carved in stone all over the world, because there has been a lot of cultural exchange since a long time. So we asked them if they knew of a granite surface 8 or 10 square meters, a vertical wall, not inclined, but a vertical wall that had been erected and polished. It doesn't exist. And besides, it would be outside, and outside is much easier than inside because there are other problems that arise when we are inside. It's the dust that we can calm it by wetting, but the more you wet, the more humid it gets. It's hot, so it's a breeding ground for bacteria. If it's dark, there's not much light. When you put people in there, as the stonemasons say, you can't work 10 people in there. After 2 hours, you have to get out. You have to ventilate. Ventilating is complicated because there's only one opening. So there you go. It's not that simple.
So are
now.
they still mysteries, actually?
These remain mysteries. We think, and it's what we say in Barabar, that it is the human hand that guided the tools. So these are tools, portable tools, not necessarily chisels. It could be other methods. Maybe they were able to mechanize certain parts. To mechanize, as I was saying, it can be quite simple. It can be you don't have to rely on complex forms of energy. It's difficult to know. We have it's difficult to determine the tools like that without having been able to do surface analysis to find out the residues of metals, of minerals that might be present in the polish, if we can find any. All these little traces, because today there are microscopes that are more optical, obviously, but that are capable of really getting into the material and determining these kinds of things. But these are equipment that does not move, that are in labs and are not transportable. So the chambers are also not transportable. We will need to wait for portable equipment that allows us to do this or to record. It won't be long before it arrives, it's going so fast that, and there we might have a little idea, but doing reverse engineering to know how it could have been done with which tools is difficult. Now I was saying to a stonemason, oh, well, yes, but today it would be simple. We would have a robotic arm that would come inside, and he told me, no, it wouldn't be that simple. You're mistaken, because, well, first of all, if we did that, we would need machines that we could dismantle and reassemble inside, given the width of the doors. You couldn't get through. We can't fit big machines inside. And then he said, when I work with machines, because today this stonecutter who works by hand uses machines for all his orders. So the guy says, you'll stop by the workshop. The workshop is a warehouse of 3,000 square meters, so it's they truly have a lot of humility, and they do a lot of things, rock cutting and all that. So
today he works a lot with computer numerical control machines, but he tells me we work in the direction of gravity, meaning that the milling machines come and cut like that when we polish. The same way our plate that we will put on top, or the desks and all that, will come in the direction of gravity, so we will take advantage of the weight to press down.
Yes, they are not walls.
Polishing vertically or vaults is even more complex because abrasive pads are needed and gravity inevitably makes them fall. You have to hold the tools, so there you have it. It's a job.
And when you say polished, it's really polished, meaning in the documentary you can clearly see that it's a surface.
It's almost glass. It's almost glass. There are comparisons. We did it. I won't give the numbers because they wouldn't mean anything to anyone here. Profilometer. All our reports are available for free on our website, open source, because the goal is for it to spread and for as many people as possible to have access to the data. And so that's baminvestigation.com. So there are reports, roughness measurements and all that. The fact is, I continue with that, and I was telling her, we can have an arm with a drill. She tells me, no, when you're working in the direction of gravity, it's okay, but if you work laterally, the longer your arm is, the more it will vibrate. The more it vibrates, the less precise it is. However, what we observe is very precise. So we can't work in that manner. Therefore, the tools really need to be very close. There must not be too much offset. He tells me working against the direction of gravity is complicated. It is really complicated. Obviously, if we wanted in our time to cut these rocks in granite, a stonemason gave us astronomical figures in terms of price.
How much is it?
They were talking in hundreds of millions. It's hard to imagine, but because of the machine, etc., it's enormous. So stonemasons might be able to do it by hand, like that today, because there is also something that must be said. According to history, these chambers would be the first and last, since there are no others. There is no equivalent anywhere else on the planet. They would be the first. The idea would have been the king would have wanted chambers to be made. He would have asked for chambers to be made. They would have been made, and that's it, finished. The stonemasons all agree. It's impossible to embark on such a project if you haven't done it before. What we see here is mastery at all levels, at the level of design, at the level of execution. When I say at the level of realization, and I paused a little, it's because the realization is done in several stages. There are several trades involved in the line of accounts. So there is a quarrying profession, quarry workers. It's in the quarries. They are the ones who remove the blocks. They are the ones who will come to remove the large blocks of material to rough cut. Then there are the crafts of the carver, because they will come with chisels to refine more and more. When there are kicks that create grooves, they will fold all that down, then gradually get closer to the shape. And then there are the people who will come to polish afterward. But there will be those who will check. And we are obliged to make symmetrical rooms inside volumes of grade 10. We are obliged to constantly check because we are working inside a material that we are hollowing out. So if we go too far, it's over. Yet everything is symmetrical.
That's what makes it extraordinary, by the way.
And it goes even further. The volumes are what they wanted to make. The volumes are not, one might say, oh damn, we missed this here. Let's enlarge a bit here, so we'll enlarge on the other side. Since we want it to be symmetrical, first it needs to be explained to us, but it is absolute. There, we decide to extend the wall, to dig the wall 1 centimeter more. We'll have to do it on the other side. Okay, but at that point, we'll change the volume, yet the volumes are coordinated with each other. And that's where it really raises a question, because we've been talking about the way to do it, the tools, etc., while staying within the limitations of the tools that were supposed to be available at that time. But now, on the other hand, it is the knowledge to be implemented for two things. The first is that we have room volumes. So these are rooms with slanted walls and with arches, sometimes made by several segments of cylinders or ribs, because we have an arch that is slightly bell-shaped, for example. That's quite complicated to calculate in terms of volumes, but normally what we do is we make portions of simple volumes that we put, and so we have a portion of ogives, a portion of circles, and we take the formulas that correspond to that. We add up all these portions of volume and we have the volume. But there, the problem that arose for the designer is different. It's that if I want to have a given volume, I want, for example, my room to be 200 cubic meters. They weren't using cubic meters at that time, but I wanted to be 200 cubic meters. At that moment, I will have to determine each dimension of the chamber, each arc of circles, determine everything to give it to the stone cutter, telling them your height is this, do not vary, do not move, your tolerance is plus or minus 2 millimeters, that's it, but you cannot go beyond that. And being able to determine all the dimensions, that is to say on paper, to determine all the dimensions so that it makes a given volume, is extremely complex. We're at a mathematical level here that is far beyond, even if we know that the Indians were very strong in mathematics, we're at a high level here. And the second thing is that we have 3 chambers that demonstrate a resonance frequency of 34.4 Hertz. And it turns out that this was determined from sound recordings of balloon bursts made according to a special protocol in the chambers. It gives them information, it gives information to the acousticians who then use those recordings because it stimulates the, I don't want to say anything incorrect because it's very specific in sound, their jargon and everything, but it gives them a recording, a sound, a sample that allows them to determine a lot of information from it because it is an explosion, it is very short and very broad.
We have a sound engineer.
Okay. From that, we determined that the first resonance frequency, I would say common to 3 rooms, is 34.4 Hertz. And there's a fourth one where it is at 34.5 Hertz with a 0.1 Hertz difference. But since we weren't sure of the temperature and temperature influences the measurements, we set that one aside and kept 3. But these 3 chambers, they have volumes that are very different. We have Vapiaka and Gopika. Vapiaka is very small. It is very small. It is 5 meters long, but it has slanted walls and it has a vault, and the entrance is on the short side. And Gopika, it is 13 meters long, so is almost 3 times the length. It is completely curved everywhere. There are only curves inside, and it has a much larger volume. And yet both will present the same resonance frequency. So there are resonance frequencies. There are quite a few inside. It's not just one frequency, but below 50 Hertz, there are very few. In Vapiaka, there is only one. In Vadatika, there is only one. In Gopika, it's 5 or 6, I can't remember, frequencies below 50 Hertz. The probability that when someone talks to me about this, it is to be excluded. So what does that mean? That these people were capable, from the very design, of anticipating the sound frequency that would be produced by the volume. What does this show once again? That we have a mastery, we know exactly how to do it, and that the Barabar chambers are not a trial run. That is to say, we have been doing this for a very long time, that we perfectly master it with a level of knowledge that is far beyond what we assume.
The question is, where does it come from? And what is the basis for all
so
this?
So now, and I've made a big digression for 2 things. On one hand, it brings us to mathematical knowledge and acoustics, but on the other hand, it's regarding the question that was asked earlier about I won't say in the difficulty of size, meaning when we're inside these volumes, we wonder how much time is needed. Are the craftsmen today, or would the stone cutters be ready to redo that? But the problem is that the stonemasons are starting from scratch there. They would first need to learn the techniques, develop the techniques, and become experts in constructing chambers for the experience to be worthwhile. Because today, either we consider that back then, the stonemasons learned that. So in about 1 generation, they learned that they were able to do it, and then for reasons unknown, no one ever did it again. So those people had that specific skill, because if it were that simple, this constancy would be found at least in India, where construction and carving continued in granite, in basalt, and almost everywhere. And not even a century after the Barabar chambers, the supposed date of the Barabar chambers, we have creations that please the eye, but they are not creations made according to the same criteria, with the same precision, the same rigor, and the same workmanship. So that means it's something not easy to achieve. And especially what the stonecutters tell us is that the guys from start to finish perfectly master the process. So all this adds to the complexity.
Where are the previous ones? Where are all the construction sites, the places, the workshops, where the stone cutters trained to achieve this mastery? Where is it located, since there is nowhere else known on the planet? In fact, there must be others. They must be somewhere, maybe they are underground. So it might be much older than we think, and that's what would explain that they are underground or under the sea. Because when we saw BAM, we know there was a catastrophe 13,000 years ago.
We'll talk about it again later. So the question of the... Do you have a question? Yes? Go ahead. Ask it.
I just wanted to ask you a question about the 70 seconds. Have you looked into it a bit, tried to find out if there were other places currently known that have such a long resonance of that size?
Not to our knowledge, but that doesn't mean there aren't any. We make reverberation chambers for precisely to test the absorption of materials. When we make reverberation chambers with very, very strong reverb, we try to eliminate resonance. We break the resonance, whereas in bar to bar, it is reverberation and resonance at the same time. So that's why in the film we say it's a textbook case, that it doesn't match what we do today. We have no use for doing this kind of thing except for contemporary art pieces. No one would venture into that because the properties are unknown. That's precisely what makes it interesting. But to our knowledge, reverberation rooms have 15 seconds of reverb. Now that doesn't mean there aren't other places that reverberate strongly, but we are at the very beginning when it comes to sound frequencies, because it's complex, because we need to find people who are creative enough to step out of their area of expertise, which is acoustics. Because generally, when we call upon acousticians, it is more to ensure that in a given place, a theater, a cinema, every spectator has the same experience, sound. So there are no, what we call nodes and antinodes. These are spots where you hear no sound, spots where you hear sound louder, so that there is no difference and there is an even distribution of sound within the space. And so, let's say 90% of the time, that's why. So it's for listening comfort, it's rather for enjoyment that we have a good experience, concert, cinema, theater play, opera, etc. Let's say that now there is a large percentage of music used for relaxation, to unwind and all, and there is a tiny percentage for health as it's in its early stages. And so today, when we called upon the acousticians, they responded within their field by telling us, no, these are not concert halls, these are not spaces designed to provide an acoustic experience, as we understand it today.
When we hear the singer in the caves, we realize that there is indeed an interest in having rooms that reverberate like that resonate like that for singing, for music.
Yes, but at the same time it is a very private experience. Spaces are not big, and furthermore the difficulty is that the more people we put inside, the more we will change the acoustics of the room, because unlike granite, which is hardly absorbent, people absorb. So if we put about 10 people, it's the same difficulties, let's say. It's just that when we filmed the singer, we had to strip down to our underwear, barefoot, because the noise of the jeans rubbing, for example, could be heard. So when we moved with the cameras, you could immediately hear the breaths and everything. Anyway, it's difficult to say why it was done, what it's for.
It remains indeed hypothetical, but we could also think of, indeed you mentioned health, but there might be resonances in terms of initiation. Are these themes, it obviously remains hypothetical, but could it eventually...
That's the question we asked ourselves, or the intuition we had often. It's because it had to do with sound frequencies, because it's the direct experience we have when we go inside. It leaps to the ears immediately. It is very curious what happens inside, and you can stay there for hours trying all sorts of vocalizations in different places, facing the wall, back to the wall, and so on. And you never stop discovering things.
Then the slanted walls remove the floating echo effect. The polymirror contributes to the diffusion of sound, thus increasing the reverberation, if I'm not mistaken. The symmetry and the volts affect the same, the propagation of sound inside. So we have 4 factors, let's say, that drive us towards the sound.
In any case, an explanation that would be related to sound.
Here. And so we say to ourselves that, yes, it's the use of sound frequencies. And now, how far do we go with the use of sound frequencies? If we concede to the Indians the fact that they are capable of making singing bowls, and then it creates frequencies, and that eventually they claim to heal people or cure people with that, or relax them and so on, well, that we are okay with. Now, the use of sound frequencies, especially when we see that if they were capable of calculating volumes to achieve 34.4 Hertz, it means that this 34.4 Hertz interests them. They didn't do it so that a television crew 2,000 years later could come and discover it. That doesn't make sense. It serves a purpose. It can't happen by chance with these 3 different volumes. So it shows a desire to have those frequencies. Now, what do we do with these frequencies? And there are plenty of questions. We tell ourselves that we are in India, where sacred singing is used to heal both the body and the soul. And that's it. Because in ancient times, no distinction was made between what we today call consciousness, let's say. So we thought, yes, why not? It would seem logical that it's a use of sound for therapeutic purposes. Now, first, that remains to be demonstrated. And second, we can very well have sessions with bowls or sacred chants or anything in a room like this one where we are doing the interview. We don't have to have mirror-polished symmetrical rooms with inclined walls and complex shapes. So there is probably something else, right? We don't know anything for now. We don't know. It's surprising when we see that we have this frequency of 34.4 Hertz appearing in 3 rooms with different shapes. So what will happen is that we will broadcast the same frequency in these 3 spaces, but it will inevitably behave differently since the spaces are different. So do we eliminate the potential use of 34.4 based on the shapes? And that's where we need fresh blood. And when we started with those researchers, because we have our abilities and that's all, and besides we don't want to arrive with this sound bias saying we think it's sound so it's sound, forgetting everything else, we tried a bit with the light, but we realized that since the walls were tilted and the floors were not completely smooth, a light beam quickly died on the floor and stopped propagating, which is not the case with sound. So then, what could it be used for?
What is also interesting is that 34 Hertz is not possible to generate with a voice unless you have special vocal techniques working with the false vocal cords, so to speak. We can't reach 30 Hertz with the voice.
It's very low. It's very, very low. We have a sample in the film, by the way, that we broadcast so people can hear it. Yeah, it's very, very low. So if there's 34, there will be multiples. So if we knew, and that's actually why we're still in it now, what we need. There, with Barabar, we have 2 hours of very technical film, lots and lots of information, not very technical, and at the same time there is feedback from the general public telling us, no, it's fine, it's good, it's pointed because it's specific, and we're always in the same place, and indeed it's also for the general public maybe less exciting than going to Machu Picchu or Easter Island, the Great Pyramid of Giza, in a Corvette where the journey takes us all over the world. Here we're kind of always in the same place. It's not, let's be honest, it's not super beautiful, it's particular, it's strange. Now, to find that beautiful, well, we can quickly grow tired of it. The more we know them, the more we find them beautiful. Yes, because the more we see the care that was taken, the more it makes the object precious. And then we think, well, it was precious in the eyes of the people who made it, to have deployed so much energy, so much effort to achieve this. It was really important to them. Now, What we need are people who can think outside their discipline, meaning that they are interested in sound frequencies, possibly interested in the impact of sound frequencies on the body. We would like to do the same, go back inside, monitor people, conduct tests with frequencies. So there is a whole process, virtual, from volumes, from recordings, to try to circumscribe a bit, because the difficulties we find ourselves confronted with the question of whether the transmitter, assuming it's someone doing it with the human voice, is the transmitter their own receiver? Is it someone who comes to sing for themselves, or is the transmitter singing for other people? If so, how many? The more people we add, the more it will change the acoustics within the frequency propagation. What is the position of the emitter? Is the emitter standing? Is the receiver sitting? We see from focus tests we've done that in Gopika. The one that is oval at 80 centimeters from the ground, there are sound focus points. So there, the acoustic experience that is of hearing the frequencies in that spot is stronger than in other places. More significant, since it corresponds to a person who will be seated and will have their ears approximately positioned at 80 centimeters. So does that mean that the people receiving were positioned there, but the person emitting, were they standing? Were they lying down? Were they at an angle? Were they outside? There was a study that showed us that a person could stand just at the entry of the volume, and it was where there was the best propagation, in any case, the most harmonious, the most uniform throughout the room. So there are many, many things like that.
Research, yes. Are you going to publish the work on scientific
We would
journals?
love to. We would
Do
love
you
to.
have contacts or leads for that?
It's difficult because when a scientist comes to work with us, some suspect him of adopting our thesis because we would all need to speak with one voice.